Hey guys, welcome to this video.
Anti-math.
So this video we're going to do trigonometric identities. So it's this one right here. This is andymath.com. I just typed trigonometric identities and it brings us to this page right here. And there are 32 examples. And we're going to do all 32 of these in this video so you can see what they all look like. So sit back, relax, enjoy learning to do 32 of these. So for the first one, cosine x secant x equals 1. The most common rule people will tell you to do with these is to write everything in terms of sine and cosine. So we're going to do that first. So this stays cosine of x, and secant of x changes into 1 over cosine of x. Now when you multiply, these cosines of x's cancel, and you're left with 1. And we get 1 equals 1, and that is what we wanted to prove. So that's the first one. Now for number 2, tangent x, cotangent x. So for this one, we'll rewrite everything in terms of sine and cosine again and see what happens. So tangent is sine x over cosine x times, and then cotangent is cosine x over sine x. So now when we multiply across for these, the sines will cancel and the cosines will cancel, which leaves us 1 equals 1. And that's number 2. For number 3, it says sine x over tan x equals cosine x. This one can be done a couple different ways, but it's definitely going to involve rewriting in terms of sine and cosine. So one way we can say sine x times 1 over tangent x. 1 over tangent x, we could rewrite that as cotangent x if we wanted. Sine x times cotangent x, because that's what 1 over tangent x is cotangent x. And then cotangent, we can rewrite that as cosine over sine. So we're still going to keep bringing down the sine, and it'll be cosine over sine. And now when we multiply these going across, the sines will cancel, and we're left with just cosine. And this one is proved. So that's one way to do it. There's a couple other ways, but they're all going to involve just rewriting things in terms of sine and cosine. So for number 4, I already have a video for that, but I'll just remake it. And all of these will actually have video buttons after this video is done. So you can come back and visit any of these and it'll skip to where it was in the video. Make it easier for you. So for number 4, secant x plus tangent x equals 1 plus sine x over cosine x. This one looks a little crazier. So for this one, we'll rewrite everything in terms of sine and cosine again. So secant x is 1 over cosine x, and tangent is sine over cosine x. Now looking at this, we have two fractions with a common denominator, so we can combine them into a single fraction with the same denominator. This will be 1 plus sine x all over a single cosine x. And that's what we wanted to prove. Check. Now for number 5, cosine x cosecant x plus tangent x equals secant x cosecant x. These are getting crazier, but they're not too bad. We'll just go through the steps. So I'm thinking rewrite everything in terms of sine and cosine again and see what happens. So this is cosine of x. And cosecant is 1 over sine plus, and then tangent is sine over cosine. Now we can put this is a times right here. So this cosine x is over 1, and it's being multiplied by this 1 over sine x. So we can just make that cosine x over sine x. So we're just cleaning it up real quick. Cosine x over sine x plus sine x over cosine x. So now this is another common theme with these. Anytime we have two fractions, we're going to want a common denominator. So the common denominator here will be sine cosine. So this left side, we're going to multiply top and bottom by cosine of x. And this side, we're going to multiply top and bottom by sine of x. And we're allowed to do this because sine of x over sine of x is just 1, and cosine of x over cosine of x is just 1. So we're allowed to do that. Now we can simplify. Cosine x times cosine x is cosine squared x over sine x cosine x plus, and sine x is sine squared x over sine x cosine x. I can change the order of them just because multiply is commutative. You can change the order of it. And I just did that so that the two bottoms would match. Now we have two fractions with a common denominator. So we can condense them into one fraction with the same denominator. So it'll be cosine squared x plus sine squared over sine x cosine x. And now cosine squared plus sine squared is 1. That's one of your Pythagorean properties. And the bottom is going to be sine x cosine x And you usually want to keep working down, but I'm going to work to the right because I just ran out of space. But this is equal to, now we can split that into the multiplication of two separate fractions. So it's going to be 1 over sine x times 1 over cosine x. And then 1 over sine x is cosecant x. And 1 over cosine. And this is basically what we have up here. You can just switch the order because once again, multiplication is commutative. Those are the steps for this one. I'll try to write smaller on the next one so they don't get so smushed. And we'll do the next one. So next one's number 6, secant x minus tangent x sine x equals cosine x. I'm thinking the same first step, rewrite things in terms of sine and cosine. So secant is 1 over cosine minus tangent is sine over cosine and then times sine x. So now we can try to simplify things. We're going to combine these two. This is sine x over 1. So this would become sine squared x. Sine x times sine x is sine squared x over cosine x. So we have 1 over cosine x, just bringing this side down, minus sine squared x over cosine x. Now we have two fractions with a common denominator. So we're going to make it one fraction with that same denominator. 1 minus sine squared x over cosine x. So now we have another one of these Pythagorean identities, and I'll show you how we can manipulate to solve this one. The official, easy to remember note is sine squared plus cosine squared equals 1. Now we want to make it say 1 minus sine squared. So we're just going to subtract sine squared from both sides. And that gives us cosine squared x on the left-hand side equals 1 minus sine squared. The whole goal is to rearrange everything to make it look like 1 minus sine squared, because that's what we have right here. And now we know 1 minus sine squared is cosine squared. So I'm going to rewrite that. Cosine squared x over cosine x. That means there's two of these on top and one on bottom. If we want, we can write it out as cosine x cosine x. It's the same thing as cosine squared x over cosine x. And those cancel, which leaves us with just alone cosine x, which is what we were trying to get to. But another way you could show that cancellation is just get rid of the square and get rid of that. And you'd write at the bottom of the problem, cosine x equals cosine x. Next one. So number 7, tangent x plus cotangent x equals secant x cosecant x. So my first step, rewrite everything in terms of sine and cosine. So tangent x is sine x over cosine x plus, and cotangent x is cosine x over sine x. We did one very similar to this a couple problems ago. So now we should already know what to do. We have two fractions with different denominators. So we want a common denominator. And the common denominator here is going to be sine cosine. We're going to multiply top bottom of this by sine and top bottom of this one by cosine. So sine x times sine x is sine squared x over sine x cosine x plus, and cosine x times cosine x is cosine squared x over, and then sine x cosine x. So now we have two fractions again, but now they have a common denominator. So we can combine them into one fraction. It's going to be sine squared plus cosine squared over the denominator, just as it is, sine x cosine x. Sine squared plus cosine squared, you have that memorized, is 1. So it's just 1 over sine x cosine x. Now since this is being multiplied, we can just make this 1 over sine x, 1 over cosine x. And if you ever feel uncomfortable about how confident you are, you could do it this way. Just remember, if we were to multiply these, it would bring us back to here. So you can always check yourself after you take a step. Now, 1 over sine x is cosecant x, and 1 over cosine x is secant x. And that's that one. Let's look at the next. Oof, getting tired. That's okay. We got this. Keep going. So the next one is number 8, cosecant squared x times 1 minus cosine squared x equals 1. So for this one, 1 minus cosine squared, this is a Pythagorean identity. So we can play with it for a second, see what that changes into. It's sine squared x plus cosine squared x equals 1. And now we're going to subtract cosine squared from both sides. So we get sine squared x equals 1 minus cosine squared x. And that's what we have here, 1 minus cosine squared x. So this changes into sine squared. You eventually have these memorized, just be able to do them in your head, but that's how it gets done. So that's a sine squared x. Then this one right here is cosecant squared x. Now, rewrite things in terms of sine and cosine. That cosecant can be changed into 1 over sine squared. And the reason the sine is squared is because the cosecant is squared. Times, and this sine squared is still on top, so we'll put a 1 on bottom. Now, when we multiply this, we're going to multiply across. So we get 1 times sine squared, which is sine squared. And on bottom, it's sine squared times 1, which is sine squared. And this is the same thing on top of itself, so it all cancels, and you're left with 1. And we get 1 equals 1, which is what we wanted to prove. So that's the end of this one. So all we did here was recognize that this is a Pythag property. We just had to manipulate it a little bit. Rewrote in terms of sine and cosine, canceled, and we were done. Let's do the next. All right, number 9, tangent squared x, cosecant squared x minus 1 equals 1. Okay, so these are getting progressively a little bit harder now. I see some squareds here, so I'm going to look at Pythagorean properties again. So I'm going to bring in some notes for this one. These are the Pythagorean identities. Now let's find cosecant squared and a 1. So here we have cosecant squared. So here we have the cosecant squared and the 1. So we're going to basically use this middle one here. And if we subtract 1 from both sides, minus 1, you can see that what ends up happening is cotangent squared x equals cosecant squared x minus 1. And that's what we have right here is cosecant squared x minus 1. So we're going to rewrite that as cotangent squared x, and then we'll just leave this as tangent squared. Now we write everything in terms of sine and cosine, the classic. Tangent squared is sine squared x over cosine squared x, and cotangent is the flip of that, cosine squared over sine squared. Hopefully this all makes sense. And then when we multiply across, stuff can cancel. And we're left with 1 equals 1. And that's how to do this one. The trick here was it was another Pythagorean identity, but it wasn't just sine and cosine, it was one of the other ones. And you just had to manipulate it a little bit to get the cosecant squared x minus 1 alone on one side, which gives the cotangent squared. And then rewrite in terms of sine and cosine, and you're done. Let's do the next. Sine x over tangent x plus cosine x over cotangent x equals sine x plus cosine x. Okay, there are a couple ways to do this one. I'll show you my preferred method. I'm allowed to break this fraction into 2 separate fractions being multiplied. So I'm going to make it sine of x times 1 over tangent x plus, and I'm going to do the same thing for this one, cosine x times 1 over cotangent x. And now I know that 1 over tangent x is cotangent x. It's one of its properties. So I'm going to rewrite this as sine x times cotangent x plus, and then cosine x, and then 1 over cotangent x is tangent x. And then we are going to rewrite everything in terms of sine and cosine. So this sine stays sine times, and then cotangent is cosine over sine plus, and then we have cosine of x, and tangent is sine over cosine. So now this is kind of nice because this sine x is over 1 and this cosine x is over 1. When we multiply across, we can reduce, we can cancel these. Same thing for these two. And we're left with cosine x plus sine x. And then we can change the order of them. It doesn't matter because addition is commutative. And that equals what we were trying to equal, sine x plus cosine x. So we're done. So if this all made sense, we can split this into 2 separate fractions and then rewrite 1 over tan and 1 over cotan, rewrite in terms of sine and cosine, cancel stuff, and we get where we ended up. So it's just kind of this flow. All right, for this next one, secant x minus cosine x equals tangent squared x over secant x. For this one, it looks like the more simplified one is on the left. So I'm actually going to do the right-hand side instead of the left-hand side. So for the tangent squared of x, let's look at the Pythagorean identities. And notice that tangent squared of x, if we subtract 1 from both sides, we get tangent squared of x equals secant squared minus 1. So I'm going to change this tangent squared x into secant squared x minus 1. So that's the first step. I have a single term on the right-hand side, this one fraction, but I have two terms on the left-hand side. I'm able to split this into two terms. I can rewrite this as secant squared x over secant x minus 1 over secant x. The idea there, if you think about it, if you're going backwards, this is having a common denominator, which would bring you back up to a single fraction. We're just doing the backward step of that. Now we just simplify. Secant squared over secant x, well, the squared and the secant can cancel, which gives us a single secant x minus, and the 1 over secant x, if you know your inverse identities, that's cosine x. And that is what we were trying to prove. And that's it. That's the answer to that one. Next, we have sine squared x minus cosine squared x equals 1 minus 2 cosine squared x. So I'm thinking Pythagorean identities again on this one. So we'll simplify the left-hand side. We have a cosine squared x, so we really want to get rid of this sine squared x. We want everything on the left-hand side to be in terms of cosine squared. And using this property right here, sine squared plus cosine squared equals 1. If I subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared. So I'm going to plug that in here. It's going to be 1 minus cosine squared x. That's just my sine squared rewritten, minus cosine squared x. So now I have two of these cosine squared x's, and they're both negative. So I'm going to write it that way. 1 minus 2 of the cosine squared x's. And now we're done. That's what we were trying to equal. Now for the next one. Negative secant x tangent x equals cosecant x over 1 minus cosecant squared x. So this is another one of those where I feel like the more simplified one is on the left. So I'm actually going to work on the right-hand side to make it look like the left-hand side. First, this 1 minus cosine squared makes me think of the Pythagorean identities. So we'll use these. 1 minus cosecant squared. We'll have to manipulate this one here. And I want to make it look like 1 minus cosecant squared. Well, let's subtract cosecant squared from both sides. So that gives us 1 plus cotangent minus cosecant squared equals 0, and then we'll subtract the cotangent squared from both sides. So with some algebraic manipulation, I was able to rewrite this one. So now for this denominator, I'm going to plug in negative cotangent squared theta. So the cosecant's still there, divided by negative cotangent squared. For the next step, let's just rewrite everything in terms of sine and cosine, simplify stuff, and then we'll make it look like the other side. Cosecant is 1 over sine. The negative's still there. And then cotangent, I'm just going to rewrite that as tangent squared on top. Then tangent squared is sine squared over cosine squared. So we have sine squared over cosine squared. And then we still have this sign that was already down here. And we bring the negative down as well. Now to simplify this squared, one of these signs gets canceled with this sign. So now we have negative sine over cosine squared. Well, if we just split this up into a multiplication of two fractions, we have negative, and then 1 over, I'm going to take one of the cosines for this fraction, times, and then the other one I'll apply to this one. So it's a little bit of manipulation, but it's very doable. So then we have the negative. 1 over cosine x is secant x. And sine x over cosine x is tangent x. And that's what we were trying to equal. So that one's done. Let's do the next one. Tangent squared x minus sine squared x equals tangent squared x sine squared x. This looks insane. I can't believe this is a real thing. So the trick here, I think, is going to be... So we could do Pythagorean identities, but we've got a tangent and a sine, and none of these have a tangent and a sine in it, in a single row, or in a single equation. So I'm going to try to rewrite things in terms of sine and cosine first. So tangent squared will be sine squared over cosine squared minus sine squared over 1. So I'm thinking we should factor out. So this is going to be something different we haven't done yet. I'm going to factor out sine squared of x, because both these terms have sine squared x in common. So I'll say sine squared x, that's factored out, and that leaves me a 1 over cosine squared x on this one, minus, and then pull sine squared out, it's minus 1. Okay, so now we got this. So this sine squared x is this sine squared x right here. So that piece is done. Now we just need to figure out what to do here. And 1 over cosine squared x is secant squared x. Secant squared x, so if we take this bottom one right here and subtract 1 from both sides, we get tangent squared theta equals secant squared theta minus 1. So I can plug in for this secant squared x minus 1 a tangent squared, and then bring down the sine squared x. Now that is what we were trying to equal. The order doesn't really matter. If you want, you could show that last step. Just switch it, and we're done. So that was something new here where we ended up factoring out the sine squared. Let's try another. Apparently sine x cosine x over all this stuff equals 1/2. Let's check it out. I feel like the first step is to FOIL this stuff out because it's just trapped underneath the square. Let's rewrite the top, sine x cosine x. And then the bottom, to distribute this or FOIL it, we'll do sine x times sine x, which is sine squared x. Then we have sine x times cosine x is sine x cosine x. Then we have this cosine x times this sine x, which I'll write as sine x cosine x because the order doesn't matter. Then we have cosine x times cosine x, which is cosine squared x. Now let us simplify the bottom. These are two of the same thing. That's going to be 2 sine x cosine x. And then this sine squared plus cosine squared can just be brought down. I just realized I forgot to bring down the -1. So you want to bring this -1 down for every step. Bringing down the sine x cosine x again. Sine squared plus cosine squared x is 1. So that's going to be 1 plus 2 sine x cosine x minus 1. So now this +1 and this -1 are going to cancel. And then this cosine cancels and this sine cancels, which leaves us a 1 on top. And so our final answer is 1/2, which is what we wanted. And that's it. So all we ended up doing here was multiplying this out, the sine x plus cosine squared, combining like terms, simplifying, and we also applied the Pythagorean identity, sine squared plus cosine squared equals 1. Let's do the next. All right, here's the next one. Sine x plus cosecant x, cosine squared x equals cosecant x. So it's kind of interesting how this guy just turns into this. Somehow this sine x and this cosine squared x are going to disappear. We'll see what happens. First step is rewrite in terms of sine and cosine. So this stays sine x plus then cosecant is 1 over sine x. And this cosine squared x is still on top. So now on the left side we have 2 terms. On the right side we have 1 term. So we're going to want a common denominator. In this case it's going to be sine. So we multiply top and bottom of the left side one by sine x. Sine x times sine x is sine squared x over sine x plus cosine squared x over sine x. Now the whole reason we did this was to make it a single fraction. So now we have sine squared x plus cosine squared x over sine x. Oh, Pythagorean identities. Sine squared plus cosine squared equals 1. So that's going to be 1 over sine, and that happens to be cosecant. And we're done. That's that one. We just rewrote in terms of sine and cosine and gave it a common denominator, then moved them to a single fraction, and then did our Pythagorean identity. So let's do the next one. So for this one, let's rewrite in terms of sine and cosine. So cotangent is cosine over sine. And since it was cotangent squared, I made it cosine squared over sine squared minus cosine squared over 1. This is another one of those where we're going to factor out the cosine squared because it's common with those two terms. That leaves a 1 over sine squared for the first one minus, and then when you pull the cosine squared x out of cosine squared x, you're left with just 1. So this cosine squared x is going to be this cosine squared x. So now we just got to deal with inside the parentheses. 1 over sine squared, let's rewrite this as cosecant squared. And now this is looking like one of our Pythagorean identities. So cosecant squared x is going to involve this middle one right here. So to make it cosecant squared minus 1, I'm going to subtract 1 from both sides. And I get cotangent squared equals cosecant squared minus 1. So cosecant squared minus 1, we know is cotangent squared. So I'm going to rewrite it. Bring down my cosine squared. And then we'll just flip the order. And that matches exactly what we're trying to equal. So this one is done. So we did Pythagorean identities and factoring out the common term. Let's do the next. So this one looks crazy. There's no way I'm going to be multiplying anything 4 times. The first thing I notice about this one is there's a square on this side. So I'm going to pull a square out of this. And that's going to look like this. Sine x plus cosine x squared squared. So now all we need to do is simplify what's inside of these brackets because we already have the squared and the squared here. So I just need to make the inside look like this piece. That's going to save me a whole lot of work to recognize that. And this isn't too bad. We're just going to FOIL this out. So I just rewrote it as sine x plus cosine x times sine x plus cosine x. Now when we FOIL it, we get sine squared x plus sine x cosine x plus, and then the cosine x times sine x, I'll also write that as sine x cosine x because the order doesn't matter. And the last one is the cosine times the cosine, which is cosine squared x. And then all of this is still squared. So now we can clean things up. Sine x cosine x plus sine x cosine x, that's 2 of those. And then cosine squared plus sine squared, I'll just bring it down. But I'm going to set them next to each other because we know sine squared plus cosine squared equals 1. Then we bring down our bracket and our squared. Now that becomes 1. It's one of our Pythagorean identities plus 2 sine x cosine x. And then this whole thing is getting squared. That's it. That's what we're trying to prove on this side. All right, next one. This is a marathon. This is a trig identity marathon. These are brutal. Secant x over secant x minus cosine x equals cosecant squared x. I'm going to leave the top alone, that's secant x, so we'll just rewrite the bottom in terms of sine and cosine. So now on bottom we have 2 fractions and we want to get a common denominator. The common denominator will be cosine x, so we're going to multiply the right-hand one, top and bottom, by cosine x. So now bring it all down, we have the secant x, and then the right-hand one became cosine squared x over cosine x. So now bring down the secant x, just leave that alone for now. And the bottom can now be a single fraction with 1 denominator, that cosine x. So it's 1 minus cosine squared x over cosine x. Now bring down the secant x again. Now 1 minus cosine squared x, that's one of our Pythagorean identities, and that ends up becoming sine squared x. And it's still over cosine x. Now we have a couple of different fractions here, but there's the top, the secant x, and then we have the bottom, which is the sine squared x over cosine x. We're going to multiply the top and bottom of that bigger fraction by cosine x. It's going to look like this, cosine x over cosine x. So for the bottom, the cosine x's cancel. And then for the top, if we think about off to the side, secant x times cosine x, that's the same thing as 1 over cosine x times cosine x, which cancels and gives us 1. So secant x and cosine x will cancel each other out and become 1. So we can cancel those 2 out as well. So now everything's been canceled, but that sine squared's there, but it's still on bottom. So it's 1 over sine squared you don't want to make the mistake of just making it sine squared. It's definitely still on the bottom part of the fraction. So 1 over sine squared, if you know your inverse identities, is cosecant squared. That's what we were trying to equal. So we're done. So let's do the next one. So for this one, there's a couple ways to do it. First, I'm going to distribute or FOIL out. So cosecant times cosine is just cosecant cosine. And then cosecant times 1 is just cosecant. The negative cotangent times cosine is minus cotangent cosine of x. And then negative cotangent times 1 is minus cotangent. So now we're just going to rewrite everything in terms of sine and cosine. Cosecant x is 1 over sine x. And cosine x is just a cosine x left on top. So we'll just leave it on top. Plus cosecant is just 1 over sine. So that one's done. Minus cotangent is cosine over sine. And then we still have this cosine here. So there's just 2 cosine x's up there. Minus, and then cotangent is cosine over sine. So this is nice. We have 4 fractions. They all have a common denominator. So we can just rewrite them all under that same denominator. But before we do that, I noticed one thing. There's a positive cosine x over sine x here and a negative cosine x over sine x here. These two can cancel, make things a little bit easier for us. So we will rewrite this as 1 over sine x minus, and then cosine x times cosine x is cosine squared x. And we wrote it as a single fraction because of the common denominator of sine x. So if you remember Pythagorean identities, 1 minus cosine squared x is sine squared x. And then just bring down the sine x from above. And then sine squared over sine, 1 cancels on bottom and 1 cancels on top. So we're just left with sine of x, which equals sine of x. And that's what we wanted to prove. So all we really had to do here was distribute or FOIL, rewrite in terms of sine and cosine, and simplify. I guess there's also Pythagorean identity and moving into a single fraction. There's quite a bit going on here, but it's all very doable. Next one. 2 sine squared x minus 1 equals 1 minus 2 cosine squared x. So immediately I'm thinking of Pythagorean identities for this one. So on the left-hand side we have a sine squared, on the right-hand side we have a cosine squared. We just want to get rid of this sine squared. And the best way to do that is from this one right here, sine squared. So if we subtract cosine squared from both sides, we know that sine squared x is equal to 1 minus cosine squared x. So I'm going to use that fact. So this will be 2 parentheses 1 minus cosine squared x minus 1. Next, I'll just distribute the 2. 2 times 1 is 2. And 2 times negative cosine squared x is minus 2 cosine squared x. And then we still have the minus 1. 2 minus 1 is 1, and then minus 2 cosine squared x. And that's what we wanted to equal. So we're done. Let's do the next one. All right, so this one's fun. We got some fourths here. So the Pythagorean identities don't really apply when it's a fourth. It's only when it's squared. But what is going on here is a difference of 2 squares. So if you remember a difference of 2 squares, if you have a perfect square minus a perfect square, it breaks down into, in this case, a plus b, a minus b. So the square root of sine to the fourth is sine squared. So I'm going to rewrite this as sine squared x plus, and the square root of cosine to the fourth is cosine squared x. And that was this first piece, the a plus b. And now for the a minus b, same values, sine squared x and cosine squared x. It's the square roots of the original values, but this one's going to be a minus. So if you remember your Pythagorean identities, sine squared plus cosine squared is 1. So that just leaves us sine squared x minus cosine squared x, which is what we were trying to equal. So we're already done. Let's do another. This one's pretty crazy. How are we going to make it a sine to the fourth of x? But our instincts are just saying let's just distribute. So 1 times 1 is 1. Then negative sine squared times 1 is negative sine squared. Positive sine squared times 1 is plus sine squared. And for the last one, negative sine squared times positive sine squared is negative sine to the fourth of x. Sine squared times sine squared is sine to the fourth. So these middle terms, negative sine squared and positive sine squared, these are going to cancel. So we're left with just 1 minus sine to the fourth of x. And that's what we're trying to equal. So we're done. So this one, all we had to do was distribute and simplify. So let's do the next one. All right, for this one, the left-hand side has one term, a single fraction. The right-hand side has two of them. So I'm going to split this into two separate fractions and simplify from there. So this is tangent of x over sine x cosine x plus cotangent of x over sine x cosine x. The idea here is since these have a common denominator, they can be combined into a single fraction. We just did that backwards. We've broken into two separate fractions. Now for each of these, I'm going to rewrite everything in terms of sine and cosine. So this tangent is sine over cosine, and then the sine x and cosine x are still on bottom, plus, now cotangent is cosine over sine. And we're going to rewrite this sine x cosine x, just bring it down. Now we get to simplify. Sine and sine simplify. Cosine and cosine simplify. So these fractions are each going to have a 1 on top. Cosine times cosine is cosine squared, and sine times sine is sine squared. Now what is 1 over cosine squared? Secant squared. And what's 1 over sine squared? Cosecant squared. And that's what we were trying to equal. So we're done with that one. Let's do the next. So first thing I notice about this one is 1 plus tangent squared is actually one of our Pythagorean identities. It's this one right here on bottom. Tangent squared plus 1 is the same thing as 1 plus tangent squared. So first thing I'm going to do is clean that up. I'm going to rewrite this as 1 minus tangent squared of x over, and then change that into secant squared of x because of our Pythagorean identity. It's just like with the last problem, we have a single term on the left-hand side and two terms on the right-hand side. So I want to split this fraction into two separate fractions. This is going to be 1 over secant squared minus tangent squared x over secant squared. So because they have a common denominator, we could combine them into a single fraction, but we're undoing that. We're breaking it into two separate ones. 1 over secant squared, if you know your inverse properties, that is cosine squared. Bring down the minus. And then for this one, let's rewrite everything in terms of sine and cosine. So tangent is sine squared x over cosine squared x. And secant is the inverse of cosine. So we're going to put the cosine on top. That's the same thing as a secant on bottom. If you want a quick reminder, cosine equals 1 over secant. So we just brought it on top. And if we square, it'd be the same thing. So that's how that works. Cosines cancel. And we're left with cosine squared x minus sine squared, which is what we were trying to get. And that one's done. Let's do the next. So this one is very, very similar to the last one, almost identical. First thing we recognize, 1 plus tangent squared is one of our Pythagorean identities. It's this one right here on bottom. So we're going to rewrite the bottom of the left-hand side as secant squared. So 1 plus secant squared x over secant squared x. Now on the left-hand side, we have a single term, a single fraction. On the right-hand side, we have two terms. So we want to split the left-hand side into two separate fractions with the common denominator. So this is 1 over secant squared x plus, and then secant squared over secant squared is just 1. 1 over secant squared is cosine squared, if you know your inverse properties. So this is cosine squared x plus 1. And we can just switch the order because addition is commutative. And that is what we were trying to equal on this side. So this one's done. Let's do another. All right, for this one, let's rewrite everything in terms of sine and cosine. So the top's going to stay sine x plus cosine x. The bottom is going to become secant x is 1 over cosine x plus, and cosecant x is 1 over sine x. So let's clean up this denominator. The two terms have a common denominator, and that would be sine cosine. So we're going to multiply top and bottom of this one by sine and top bottom of this one by cosine. So right now we're just cleaning up the denominator. So I'll bring down the numerator, sine x plus cosine x. And then for our denominator, we have sine x over sine x cosine x plus cosine x over sine x cosine x. So now we're still looking just at the denominator. This two fractions now have a common denominator, so we can write them as a single fraction. So we'll bring down the sine x plus cosine x, but the bottom is now going to be sine x plus cosine x over sine x times cosine x. So we got sine x plus cosine x in the numerator. In the denominator, we have sine x plus cosine x over sine x cosine x. Now what we're going to do is multiply the top and bottom of this one by sine x cosine x. So we're multiplying the bigger fraction by sine x cosine x. So what happens is this term cancels with this one. Sine x cosine x cancel. And this sine x plus cosine x is its own term being multiplied. These also cancel. So all we're left with is sine x cosine x. Which is what we were trying to equal. So that one took a little bit of funny manipulation, but that's it. We're done. Hope that one makes sense. Cool. Let's go on to the next one. So for this one, we're going to rewrite everything in terms of sine and cosine. So cosecant is 1 over sine, and secant is 1 over cosine. And in our denominator, cotangent is cosine over sine, plus, and tangent is sine x over cosine x. Now we just want everything to have a common denominator, so we're going to multiply top and bottom of this one by cosine of x, and top bottom of this one by sine of x. And then for this one, we're going to multiply top and bottom by cosine x, and top bottom of this one by sine x. So both the numerator and the denominator have the same common denominators for their individual fractions. We'll simplify it. So this is cosine x over cosine x sine x plus sine x over cosine x sine x. And that was just the numerator. All over, and then cosine times cosine is cosine squared x over cosine x sine x plus sine squared over cosine x sine x. So I'm going to shrink this down. Give me a little bit more room to work. So the top we can write as a single fraction. This would be cosine x plus sine x over cosine x sine x. Once again, all of that is over cosine squared x plus sine squared x, all over cosine x sine x. So now ultimately we are dividing fractions here, so we can flip the one in the denominator and multiply it by the one on top. So I'm going to say times cosine x sine x over cosine squared x plus sine squared x. And now this has gone down here. Well, cosine x sine x on bottom and cosine x sine x on top will all cancel. So those are gone. And cosine squared plus sine squared, that's 1. So then we're just left with cosine x plus sine x, which when you change the order, sine x plus cosine x, it's what we were trying to equal. Sine x plus cosine x. That's it. And now that one's done. Let's do another. It's just 5 more. We got this. This one's pretty standard. There's 2 terms on one side, 1 term on the other. So we need to combine these 2 fractions into a single fraction using common denominator. So we're going to multiply top and bottom of this left side by 1 minus cosine x. And on this side, we're going to multiply top and bottom by sine x. So it's going to be 1 minus cosine x times sine x. This we can multiply out. So 1 times 1 is 1. Then we have a negative cosine x and another negative cosine x. And then negative cosine times negative cosine is positive cosine squared. Plus, and then sine x times sine x is sine squared x. And this is also over 1 minus cosine x sine x. Now, since these have a common denominator, we combine them into a single fraction with the same denominator, 1 minus cosine x times sine x. And notice how I didn't distribute the denominator. Sometimes you want to leave them separate. So I wouldn't distribute it until you think you're going to need it. For this top, we got 1. This one and this one are the same. So it's going to be minus 2 cosine x. And then we have a plus cosine squared x plus sine squared x. So cosine squared plus sine squared is 1. And then we have this 1 right here as well. So that's going to give us 2 minus 2 cosine x. And everything else is gone on top. And on bottom we have 1 minus cosine x times sine x. So I'm going to shrink it to get a little bit more room. So now we're going to factor out a 2 on the top. So it's 2. That leaves us 1 minus cosine x, because you pull a 2 out of each of those 2 terms, divided by 1 minus cosine x times sine x. These 1 minus cosine x's, since they're both factors of the top and bottom, can be canceled. So we're just left with 2 over sine of x. If you know your inverse identities, 1 over sine of x is equal to cosecant of x. So we have 2 cosecant of x, which equals 2 cosecant of x, the thing we're trying to prove. So now we're done. Let's do the next one. This one I can't see how to do it in my head, so we'll try the conjugate first and see what happens. So we're just going to FOIL or distribute at the top and bottom. So 1 times cotangent is cotangent x. 1 times negative cosecant is negative cosecant x. Secant times cotangent is positive secant x cotangent x. And secant x times negative cosecant x is minus secant x cosecant x. Then on bottom, 1 times 1 is 1. Then 1 times negative secant x is negative secant x. Positive 1 times secant x is plus secant x. And secant x times negative secant x is negative secant squared x. These middle terms cancel on bottom. And on top, I think we're going to have to rewrite everything in terms of sine and cosine. So this cotangent is cosine x over sine x minus cosecant is 1 over sine x plus secant is 1 over cosine x and cotangent is cosine over sine minus secant x is 1 over cosine and cosecant is 1 over sine. And that's just the numerator. In the denominator, we still have 1 minus secant squared. So on the top, these cosines cancel. And then this negative 1 over sine and this positive 1 over sine, these are going to cancel as well. So for this numerator, the common denominator for these 2 terms would be cosine sine. So I'm going to multiply top and bottom by cosine. So now we'll just rewrite this. This is cosine squared minus 1 over cosine sine. And that's the numerator. And the denominator is 1 minus secant squared. Now let's use Pythagorean identities to clean these up. 1 minus secant squared, that would be this bottom one here. So if we subtract secant squared from both sides, subtract tangent squared, that gives us negative tangent. I won't do the work here, but hopefully you know how to manipulate these Pythagorean identities. If not, there's probably a page on andymath.com to practice doing that. But we're going to rewrite this bottom as negative tangent squared of x. And then cosine squared minus 1. If we bring the negative 1 over negative sine, this would be negative sine squared. And then we still have the cosine sign. So we'll just simplify this one step at a time. The negatives are going to cancel, so they'll both become positive. And then this sine is going to cancel with that sine. And so basically we have a sine over cosine. So on top we have a tangent of x. And on bottom we still have this tangent squared of x. So that'll simplify, get rid of one of them on bottom and the one on top to 1 over tangent of x. And 1 over tangent of x is cotangent of x. So sorry, space got tight, but now we have cotangent x equals cotangent x. And that's that one. So that one's crazy. I had a feeling it'd be crazy, but we got through it. Let's do the next one. Tangent squared minus sine squared. So first step, rewrite everything in terms of sine and cosine. So this would be sine squared over cosine squared minus sine squared. So looking at both of these, I see a sine squared on top. That's a common term. If you ever have a common term on bottom, that means common denominator. If you ever have a common term on top, you usually want to factor it out. So since we have a sine squared x on top, let's factor it out. It's actually a pretty good rule to know. If you ever have something uncommon on bottom in the denominator, you're probably going to combine the fractions and make a common denominator. But if you ever have something common on top in the numerator, you're going to factor it out. Like this. So sine squared over cosine squared, pull the sine squared out, you get 1 over cosine squared. Minus, and then sine squared, pull the sine squared out, we just get a 1. Now this sine squared is this sine squared. So that piece is done. We just got to clean up inside these parentheses. 1 over cosine squared is secant squared. So I'm going to bring down my sine squared. Always want to keep bringing down every piece, even though you know you're done with it. 1 over cosine squared is secant squared, if you know your inverse identities, minus 1. Now we're going to use one of our Pythagorean identities. So we're going to use this bottom one. We're just going to subtract 1 from both sides. And that shows us the secant squared minus 1 is tangent squared. I'll actually write it out. So I'm going to substitute for the secant squared minus 1, a tangent squared. You can change the order of them. That doesn't matter because multiplication is commutative. And that is what is on this other side. That's what we wanted to prove. On to the next one. So this one has secant fourth, tangent fourth. Usually there's nothing you can do with the fourths because the Pythagorean identities don't work with the fourths. So we're going to have to factor this. And this is a difference of 2 squares. So the square root of secant to the fourth is secant squared plus tangent squared, because that's square root of tangent fourth. And then we have secant squared x minus tangent squared. So we just applied the difference of 2 squares. That was it. Let's look at our Pythagorean identities and see what we got. Okay, this secant squared minus tangent squared, we can manipulate this bottom one by subtracting tangent from both sides. And so we get 1 equals secant squared minus tangent squared. So this secant squared minus tangent squared is going to be just 1. And then on this side, this is still here, secant squared x plus tangent squared x. But that is what we were trying to equal to, secant squared x plus tangent squared x. So we're done. Just copy it down. And that's it. Thanks for joining me. All these trig identities are on andymath.com. They'll all have video buttons when I'm done editing all this. And you guys can practice them on your own. Feel free to check out andymath.com if you have anything else you want to look at, because there's a bunch of stuff here. Please like this video, subscribe to my channel. Thanks for joining me again. I'll talk to you guys soon. Bye.